Hey everyone, and welcome back. We're diving into the world of software development today
Super fun.
with a blog post actually
That's so cool.
from Algo Academy, and it's all about how to avoid over-engineering.
Okay.
And you might be thinking, software development, not really my thing.
Yeah.
But hold on, because this deep dive
Right.
it's actually relevant whether you write code or not, because we're really talking about finding that sweet spot
Okay.
between like a solution that works
Yeah.
and one that's just like way too complicated. And
Yeah.
we've all been there.
For sure.
Like, why use a simple paperclip when you can like construct some crazy elaborate thing with string and pulleys and
Yeah, like a Rube Goldberg machine almost.
Yeah, exactly. A Rube Goldberg machine to like turn on a light switch.
Right. Exactly.
Yeah.
And in software,
Yeah.
that tendency to overcomplicate things is called over-engineering.
Okay, so over-engineering.
Yeah.
I'm loving these analogies already. So it's about like keeping things simple and elegant.
Exactly.
But why is this such a big deal? Especially in like the world of coding interviews where it's so fast-paced.
So let's imagine you're in a coding interview.
Okay.
And you have like a really limited amount of time to show off what you can do.
Right.
If you spend all that time making something super complex,
Yeah.
when a simpler solution would have worked just as well.
You're going to run out of time?
Yeah, it's a recipe for disaster. You're going to run out of time.
Right.
And also complex code, it's like a breeding ground for bugs and errors.
Oh, it's like trying to build a house on a foundation of playing cards.
Exactly. One wrong move,
And the whole thing
collapses.
Yeah.
And here's the thing.
What's that?
All that extra effort you put in,
Yeah.
it might not even actually solve the problem effectively.
Right.
You could end up with this like convoluted mess of code
Yeah.
that's really difficult to understand and maintain and update in the future.
Okay, so it's all about finding that balance then, right? Yeah.
Between a solution that's functional,
Exactly.
but also not like ridiculously complex.
Yeah, keep it simple.
And the Algo Academy blog post actually gives us some really interesting strategies for avoiding this trap.
Yeah.
So we're going to kind of break those down.
Yeah, let's dive into them.
Okay, so the first one they talk about is starting with what they call a brute force approach.
Yes.
Okay, so brute force, what does that even mean?
So basically it means finding the most straightforward way
Okay.
to solve the problem, even if it's not the most elegant or efficient
Right.
at first.
Okay.
But it helps you understand the core problem before you start adding all the bells and whistles.
So it's like a rough draft before you really get into it.
It's like if you were trying to count how many times each word appears in a book.
Oh, okay.
You could use a simple dictionary to do that.
Yeah.
Instead of designing some really complex algorithm.
Got it. So just strip away all the unnecessary complexity.
Yeah. Focus on the core functionality first.
Exactly.
Now they give an example
Yeah, they do.
of how to do this. And I can already hear some of our listeners saying,
Oh.
wait, hold on, code. This was supposed to be for everyone.
Right.
But before we get into the weeds,
Okay.
could you maybe just help us non-coders understand what this example is all about?
Absolutely.
Okay.
So imagine you have a list of numbers
Okay.
and you need to find the section of that list that adds up to the highest total.
Right.
The brute force approach would be to just systematically check every single possible section, add up the numbers, and then compare them to find the largest sum.
So it's like trying every single combination on a lock.
Yes, exactly.
Until you find the one that opens it.
It might not be the fastest way,
Yeah.
but it gets the job done.
Right.
And it makes sure you really understand the problem thoroughly before you start trying to optimize.
So you're laying the foundation.
Yeah, exactly.
Before you start building on top of it.
Exactly.
Okay, what's the next strategy?
So the next one is to stick with basic data structures.
Okay.
Like arrays or dictionaries.
I'm assuming data structures are like ways of organizing the information in the code.
Think of an array.
Okay.
Like a numbered list of items.
Okay.
And a dictionary, like a set of key value pairs, similar to a real dictionary where you have a word and a definition.
Got it.
The point is you don't need to jump into more complex structures.
Unless you absolutely have to.
Right.
Okay.
They actually have a code example here
Okay.
to show how sticking with the basics can really make your code cleaner and easier to understand.
So keeping it simple
Yeah.
with the organization helps avoid unnecessary complexity in the code itself.
Exactly. And, even if you're not a coder, the takeaway here is
What's that?
it's about choosing the right tool for the job.
Right.
Don't overcomplicate things.
Yep.
You don't need a fancy power tool when a simple hammer will do.
Choosing the right tool for the job.
Exactly.
I love that. And that applies to so many things.
It does.
Not just code.
Right.
Okay, what's the next one?
Okay, so next they talk about tackling the core functionality first.
Okay.
Before you get bogged down in edge cases.
Okay, wait, edge cases, what are those?
So edge cases are those unusual or extreme scenarios that you might encounter.
Right.
So it's like planning a road trip.
Okay.
You focus on the main route first.
Right.
And then you worry about any detours or alternative routes later.
You don't want to get sidetracked.
Exactly. You don't want to get sidetracked.
By every possible what if.
Right.
Before you even start.
Exactly.
Yeah. Okay. Makes sense.
So get the main part working and then fine tune it.
Right.
Actually, they have an example here.
Of course they do. Another code example?
Using binary search.
Binary search. I'm not a coder.
Right. So imagine you're looking for a specific word in the dictionary. You don't start at the beginning and go through every single word.
Right. I just open it up somewhere in the middle.
Exactly. You open it up in the middle.
Yeah.
See if the word you want is before or after. And then eliminate half the dictionary.
Right.
You keep repeating that.
Okay.
Until you find the word.
So it's a more efficient way of searching.
Exactly. And this example shows how to apply that same principle to your code.
Got it.
Focus on the core search functionality first.
Right.
And then worry about those rare, unusual cases later.
So prioritize.
Yes.
And then fine tune.
Exactly.
I like it.
All right. What else?
Okay. So the next one is what they call modular code.
Modular code.
Yeah.
All right. Break that down for me. I'm not a coder.
Okay. So think about organizing a really messy room.
Okay. I could do that.
Instead of having everything just piled up in one giant heap.
Yeah.
You put things into labeled boxes that clothes in one box, books in another box.
Electronics, whatever. Exactly. This makes it so much easier to find what you're looking for.
Right. It makes it easier to keep things organized.
Exactly. And that's what modular code is all about.
Okay.
Breaking down your code into smaller, more manageable pieces.
So those labeled boxes within your code.
Exactly.
To keep everything organized.
They use an example.
Oh, here we go again.
Called the two-sum problem.
The two-sum problem. Okay.
So imagine you have a list of numbers and you need to find two numbers.
Okay.
That add up to a specific target number.
Right.
The code example shows how to break down this problem into smaller, more reusable pieces.
So you're not trying to solve the entire problem.
Right.
At once, you break it down into
smaller steps.
More digestible steps.
Yeah, exactly. Right. And this makes it easier to read and understand.
Okay.
Easier to fix errors.
Right.
Easier to make changes later on.
That's fantastic. Now, we've been talking a lot about keeping things simple.
Yes.
Avoiding complexity.
Right.
What about optimization?
Optimization is important.
Right.
But timing is key.
Oh, okay.
It's like adding sprinkles to a cake.
Okay.
You do that after the cake is baked.
You don't do it before.
Not before.
You got to make sure the cake's good first.
Exactly.
Yeah.
Make sure the cake is good.
And then worry about the sprinkles.
Then you can worry about making it pretty.
Okay, so first you get your code to work.
Yes.
And then you think about making it faster or more efficient.
Exactly. And the Algo Academy blog talks about optimization.
Okay.
In terms of time complexity and space complexity.
Okay, break those down for me. What are those?
So time complexity is how long it takes for your code to run.
Okay.
And space complexity is how much memory your code uses.
Okay, so you want your code to be
efficient,
fast, but also not a memory hog.
Right. You want it to be lean and mean.
So it's like the difference between a car that can speed down the highway versus a car that gets great gas mileage.
Exactly.
You kind of want a car that can do both.
Right. And the blog gives some insight into how to kind of balance those things.
This is fascinating. It's like a whole new world
It is.
opening up to me, even though I'm not a programmer.
And that's the beauty of these principles.
Yeah.
They apply far beyond just software development.
Right.
They're about problem solving and finding that balance between simplicity and efficiency.
I'm already seeing how these concepts could apply to like my own work and my own life.
Absolutely.
This is great. This is an eye-opening discussion.
I'm glad.
We're going to dive deeper into those specifics of optimization and finding that balance.
That's good.
In the next part of our deep dive, so stay tuned.
All right.
Okay, so we're back.
Yes.
And ready to kind of unpack some more of these strategies for avoiding over-engineering.
Right.
Before the break, we were talking about optimizing code.
Yes.
Making it faster
and
more efficient.
More efficient, exactly.
And the Algo Academy blog gives some really good examples of how to actually do this.
Yeah.
So remember that brute force method we talked about?
Yes.
For finding the maximum sum of a subarray?
Right.
Like, it worked.
It worked, yeah.
But it wasn't necessarily the fastest approach.
No, it wasn't the most elegant.
Right. It was like trying every combination on a lock.
Exactly.
Not really elegant.
Not very efficient.
So the article shows us how to optimize that same problem to make the code run much more quickly.
Right.
So instead of like recalculating the sum of every single subarray, it uses this clever technique
to
keep track of the current maximum sum as it's moving through
as it goes.
The list.
Yeah.
So it's like finding a shortcut through a maze.
Yes.
Instead of just like
blindly going down every path.
Yeah, blindly trying every path.
That's a great analogy.
And then when it comes to space complexity, remember, that's all about how much memory.
Yes, how much memory the code uses.
The code uses.
Yeah.
They give an example of reversing a string.
Yes.
Reversing a string.
One way to do it would be to create a whole new string.
Yeah, you could create a new string.
And fill it in reverse order.
Uh-huh.
But the optimized version.
Yes.
It actually manipulates the original string in place.
It does.
Which saves a ton of memory.
Yes. Much more efficient.
So it's like rearranging the furniture in a room.
I was going to say that.
To create more space instead of like buying a whole new house.
Yes. That's perfect.
I'm loving these analogies.
They're great.
But you know something I think is really important?
What's that?
Optimization isn't just about like making things faster or leaner.
Right.
It's also about
readability.
Yeah, making your code readable.
Yes, making it understandable.
Understandable for other developers.
Other developers, exactly.
Or even for your future self.
Yes, because who wants to go back and try to decipher code?
That looks like hieroglyphics. That looks like hieroglyphics, exactly.
Yeah.
So the article recommends using meaningful names for your variables and functions, adding comments to explain complex parts.
Right.
And refactoring repetitive code into reusable functions.
So basically like treating your code like you would treat a guest in your home.
Exactly.
Make it welcoming.
Welcoming.
Easy to navigate.
Easy to navigate.
Don't be afraid to label things.
Label things clearly.
Yeah.
I love that analogy.
So remember, in the end, it's all about
balance.
Yeah. Finding that sweet spot.
It's sweet spot
between functionality and optimization. And the Algo Academy blog.
Yeah.
Gives us some tips.
Gives us some tips.
For finding that balance.
Okay, I'm all ears.
Okay, so first and foremost, communication is key.
Okay.
Especially in an interview setting.
Right.
Don't be afraid to articulate your approach to the interviewer.
Yeah.
Let them know you're starting with a simple functional solution.
Right. And that you plan to optimize later.
Transparency.
Transparency, exactly. This shows that you have a plan.
You're thinking strategically.
Yes, that you're thinking strategically.
Okay, love it.
Next, consider implementing your solution in stages.
Okay, in stages.
So start with the basic functionality, then tackle those edge cases we talked about.
Right.
Then optimize for time complexity.
Okay.
And then finally, optimize for space complexity.
Okay.
And of course, throughout this whole process, make sure your code is clean and readable.
It's like building a house, right?
Exactly.
Foundation first.
Foundation first.
Then walls, then roof.
Then the roof.
And then you worry about the fancy decor.
Then you add the chandelier.
Exactly.
You don't hang the chandelier before you have a ceiling.
You don't put the cart before the horse.
Exactly. And here's a crucial point.
Okay, what's that?
Know when to stop optimizing.
Oh, okay.
If your solution is working well, and it meets the requirements, it might be better to just discuss further optimizations.
Right.
Theoretically.
Instead of actually implementing them.
Right. Especially in a time-constrained setting.
Like an interview.
Like a coding interview, yes.
Sometimes good enough is good enough.
Exactly.
You don't want to get so lost in the weeds that you forget to solve the actual problem.
You got it.
Okay.
And finally, take the time to reflect on your approach.
Okay.
After each coding challenge, think about what worked well.
Okay.
What could have been better, and how you can improve your balance.
Yeah.
Between functionality and optimization in the future.
So it's not just about the code itself, it's about
It's about the process.
Yeah, developing those good problem-solving habits.
Exactly. And those habits apply to any field.
To any field, not just coding.
Not just coding.
I'm already seeing how these concepts could help me be more efficient and organized.
I'm so glad.
In my own work, and I'm not even a programmer.
That's what's so cool about these principles.
Right.
They're transferable.
Yeah.
So many different areas of life.
It's all about like finding that sweet spot.
That sweet spot.
Between getting things done.
Yes.
And keeping things simple.
Exactly.
Oh, man. This has been so insightful.
It has been fun.
I feel like I've learned so much about software development, but also just about problem solving in general.
All about problem solving.
It really is.
At the core.
Well, this has been a great discussion.
It has.
Thanks so much.
Of course.
We're going to take a quick break.
Okay.
And when we come back, we'll wrap up our deep dive.
Sounds good.
Into the world of over-engineering with some final thoughts.
Awesome.
And maybe even a little challenge for you to ponder.
Ooh, I like it.
Stay tuned. Okay, so we're back, and I am still thinking about all that stuff about optimization.
Yeah, it's really cool, right?
It's so fascinating how these like technical concepts can actually apply to everyday life.
It's true.
Like space complexity.
Yeah.
Who knew?
Well, it just goes to show you that software development, at its heart, is all about problem solving.
Right.
And good problem solving skills are valuable.
Absolutely.
No matter what you do.
No matter what you do. So as we're wrapping up this deep dive into the world of over-engineering, what would you say are like the most important takeaways?
Okay, so I think the biggest takeaway is to approach any problem, whether it's coding or anything else, with a focus on functionality first.
Okay.
Get something that works, then worry about making it better.
Right.
Don't get so caught up in trying to find the perfect solution.
Right. Don't let perfect be the enemy of good.
Exactly. Get something working.
Yeah.
And then iterate.
Iterate.
Refine. Improve.
I like it.
And remember, communication is key.
Oh, yeah. Especially in those coding interviews.
Especially in an interview.
You guys.
Let them know what you're thinking.
Explain your thought process.
Explain your thought process.
Show that you're aware of potential optimizations.
That you're thinking about it.
Right.
And that you're willing to learn and adapt.
So it's not just about having all the fancy code tricks.
It's not about showing off all the fancy tricks.
Right. It's about showing that you have
a solid approach.
Yeah, like a good approach to problem solving.
Yeah, exactly.
I love it. Well, a huge thank you to the Algo Academy blog.
Thank you, Algo Academy.
For this thought-provoking article.
It was great.
It's really given us a lot to think about.
A lot to think about.
And to all of you amazing listeners out there, I want to leave you with a little challenge.
Okay, hit me.
Think about areas in your own life or work where you might be over-engineering solutions. Yeah. Are you building a bookshelf?
Right.
Or are you building a Rube Goldberg machine?
Ooh, I like that.
You know. Could you benefit from a simpler, more direct approach?
Sometimes simple is better.
It's just something to ponder.
It is.
As you're going through your day-to-day.
Absolutely.
Well, thank you so much for joining us.
This was fun.
On this deep dive into the world of software development.
Yes.
And beyond.
And beyond.
Until next time, keep those minds curious.
Yes.
And don't be afraid to keep things simple.
Keep it simple.
We'll see you next time. Bye, everyone.